if in Rutherford's experiment the number of particles scattered at 90-degree angle are 28 per minute, then the number of scattered particles at an angle 60-degree and 120-degree will be. So number of atoms scattered or number of particles scattered is given by the formula n of theta is equal to kz square by sin theta by 2 to the power 4, sin theta by 2 to the power 4 into kinetic energy square. So for theta equal to 90 degree, that is n of 90 is given as 28. N of 90 is given as 28. That is equal to kz square by sin to the power 4 theta is 90 by 2 into kinetic energy square, kinetic energy whole square. Now 28 is equal to kz square by sin 45 is 1 by root 2, 1 by root 2 to the power 4 ke square. Now that can be written as further kz square by ke whole square into 1 by root 2 square whole square, no, so 2 square, that will be 1 by 1 by 4. So that gets multiplied here. 28 into 1 by 4 is kz square by ke whole square, which is 7. This is our equation star. Okay. Now for angles 60 degree and 20 degree, 120 degree. So n of 60 degree will be the same formula, kz square by sin 60 by 2 to the power 4 into kinetic energy whole square. This thing we have found out. How much it is? 7. It is 7 by sin 30 to the power 4. Sin 30 is half. Sin 30 is half to the power 4. Half to the power 4 you are going to get. So that will be 7 by 1 by 16 it will be, which is 7 into 16, 112 per minute. So among the options 112 appears only in option A. So right away you can write this as option A. However, we can also try for 120. The formula looks similar, kz square by kinetic energy whole square into 1 by sin 120 by 2 to the power 4. So this whole thing is 7, which we have calculated from here. 7 into 1 by sin 60 to the power 4. So sin 60 is root 3 by 2 to the power 4. So that will be 2 to the power 4 is 16. Root 3 square is 3 and by 9 it will be. That will be by 9. So 112 by 9 you are going to get, which comes out to be around 12.5 per minute. So the answers are 112 per minute and 12.5 per minute. So option A is the correct answer.